There we go. Okay, guys. This is going to be. Oh, there we go. All right, this is going to be the video for drawing bar graphs. Now I'm going to do this one here, number 10, and I realize that this is exactly the same as on the previous review. But I'm leading it because I really like it. I couldn't come up with another one that I liked as much as this, and I feel like it's worth us looking at again. So I'm going to read it. A car starts at the bottom of the ramp sitting against a compressed spring. That's right here. Okay, so it starts down here, and it says point A is the car not moving, but my spring is compressed. The spring is then released. The car travels up the ramp and until it slows down to a stop. Create bar graphs representing the energy at each point. Now, what is a little bit different, I went ahead and I labeled these things a little bit better. So at A, the car's not moving. At B, the car is moving and it's not touching the spring. At C, the car's at its highest point and it's not moving. So those give us a lot of clues. So let's look at point A first. All right, so the car is not moving. So right away, I know that there's no EK. But I do see that it's compressed against the spring. So I'm going to go ahead and just put all my graphs in here. So I have EG, EK, EEL, and ET. And a good idea for you guys is to just go ahead and put all of those on each one. So now I don't have to mess with those anymore. Okay, so the car is not moving. I know it doesn't have any height, but it is compressed. Why does it keep doing that? Okay, it is compressed against the spring. So here's what I know. This is all EL. Okay, because I can't have any of the other stuff for those reasons I said. All right, I can't have EG because it doesn't have any height. I can't have EK because it's not moving. So it must be EL because it's compressed against that spring. And that means that my total bar, oh man, I messed up. You guys scratch these things out. That's confusing. ET is thermal. We're just going to do total. Total. And total. Like that. My bad, guys. Okay, so that's it for A. Now B, the car is moving. It's touching the spring, so it's kind of right in this area. So now it's not touching the spring, so I know that it's not going to have EL. And it doesn't have any height yet because it hasn't started going up the ramp. Okay, so I know it's not going to have any EG, but it is moving, so that means it can have EK. So in part A, the spring was where the energy was at. Now the energy is in the movement. It's still the same amount of energy, so my total is still the same. Okay, now part C says the car's at its highest point and it's not moving. So again, it's not moving, so I cross off EK. It's not touching anything elastic, so I cross off EEL. But it's at its highest point, so now all of a sudden it finally has some height. It didn't have height before, but now it has height. So that means that all of that energy has changed into EG, gravitational potential. And our total stayed the same for all three. That's really important to see that all three totals are exactly the same. It just changes from EEL to EK and then finally into EG. If you have questions on the next one, it's a little bit harder. Make sure that you ask me.